Okay, so we're going to take a look at Journal 42. So today, our bell work, I want you guys to try out these two problems and see how they are similar and how they are different. Okay, so when we're looking at these two problems here, we can see that they're the same numbers inside. We call this number here a base. And we can see that this base here is being squared and then cube rooted, whereas this one is being cube rooted first and then squared. So let's try out A, and then we'll try out B and see how they are different and the same. So if I'm working out this problem for A, I need to do the inside of the root first. In other words, I have to take 8 and square it. Well, 8 times 8 is 64. And then it looks like I have to cube root it. Well, the cube root of 64, you can put in your calculator. Just hit that math. And then option 4. And then you'll be able to get the cube root function. And then stick whatever number you want inside the cube root. So if you do that, let's see what you would get. If you did a factor tree, it'd be like 8 times 8, break it down. 8 can be broken down as 4 times 2, 4 times 2. 4 can be broken down as 2 times 2. And it looks like I'm left with my prime. So if I highlight all my prime numbers, you can see, let's see, all the 2's are my prime numbers, it looks like. And what you have to do if this is a cube root is you need to circle all your triples. Okay, 3 of the same numbers. So let's group them up. So it looks like I have this one, this set of 2's, and then I have this set of 2's. So if one of my triple is 2 and the other one is 2, well, 2 times 2 gives you 4. So it looks like my cube root of 64 is 4. And so that is my first answer. Let's try out problem B. So problem B here, looks like we have to cube root the 8 first instead of squaring it. So let's go ahead and do that. I'm just going to do a factor tree. This one's not too bad. So 8 can be decomposed as, 4 times 2, and then 4 can be decomposed as 2 times 2. And so it looks like I have a triple of 2's again. So I have, 2's here. So the cube root of 8 is 2. And then I have this square that's outside, so I still have to square my 2. So 2 squared is 4. And would you look at that? It looks like I have reached the same solution as I was before. So these both give the same answer. Well, what does this mean? Well, this means that it doesn't matter the order which you do your exponent or taking the root. Notice how we took the square of this first, the exponent first, and then we took care of the root. Whereas this one is the opposite. We took care of the root first and then we did the exponent. So we can say that it doesn't matter if you take the root first or the exponent first. You will arrive at the same answer. So the order of whether you do the root first or the exponent doesn't matter. And this is going to help us with an advantage when we're dealing with bigger numbers. And you'll see why in the next few slides. Okay, so our first slide for today, let's talk about rational exponents. Now, I know you guys should be pretty familiar with what exponents mean. They're just referring to power. And so like this a is to the m power, or the exponent is m. But rational we don't talk about very much. So you're gonna start hearing me say this word. And anytime you're thinking about rational, it's really referring to I can express something in a fraction form. Okay? Whether that be numbers or variables, I can express it as a fraction. And you can see here, since we're talking about rational exponents, I have exponents that look like fractions, right? And we're going to talk about how they are related to radicals, because they are. So what we're going to do first is take a look at this formula here. It is not a complete formula. It's missing quite a few things. So we're going to try to add back what it's missing. So looking at this here, I have a to the m power, and n is our root. Now, we've been doing where we take the exponent and divide it by the root, right? We always take the exponent and divide it by the root. Well, isn't that just saying I'm taking m and I'm dividing it with n? And doesn't that look quite like a fraction? And when we take a look at this fraction, notice that the exponent, the m, is in the numerator, whereas the n, the root, is in the denominator, which makes sense because you're dividing by the root. So from our bell work, we also learn that the order of the way you take the root or the exponent doesn't matter. So you can take the root of the a first and then take the exponent m. So that's going to help us out later, but let's try out these problems below. So it says here to rewrite or write the radical or the exponential form. So you can see here I have these two that are both exponential forms because they have an exponent. And that means we have to write it as a radical form instead. So let's try it out. So we always first start out with our, well, you don't have to, but I like to start out with writing a radical. And then I ask myself, okay, what's my base? Well, my base is x, so x goes in. And then my exponent here is going to be the 1, right? Because that's in our numerator, so 1 is going to be here for x. And then the 5 is in the denominator, so that's my root. And so I have the 5th root of x to the first power. You don't have to write that 1 there, I just happen to, so you can see where the 1 went. And so that is my answer. So let's try out 81 part B next. So this one here, I'm going to do the same thing. It's in exponential form, so I'm going to write it as a radical. 81's my base. The exponent, the numerator, is a 3, and my my root here is a 2. So in this case, I'm taking the square root. And so there we have it. That is our answer. We've just rewrote it as a radical. So for part C and D, it looks like we have a radical this time, so now we have to write it as an exponent, okay? So that means we need to write it as, we need to know what our base is and our fraction exponent, or our radical exponent. So let's try this one out. So our base here obviously is this x, right? And in this case, our exponent is going to be, looks like our 9, right? And then our root is 5. So I have 9 over 5. And there we have it. We have we have written it as an exponent form. Okay, last one. This one might be a little bit tricky. So 21 is definitely our base. And 7 is definitely our root. But what is our numerator for our exponent? Well, in this case, 21 can also be raised to the first power, right? If there's not a power, that by default, it's always to the power of 1. So this case here, we have 1 over 7 as our power. And that's it. So let's try out the next slide next. Okay, so now we're going to take a look at, let's see here, let me move this over a bit. We're going to take a look at evaluating expressions. So here I have a few numbers. We're going to try to simplify it down, and then I threw in a variable just so that we can, slowly build our skills to working with more variables. But let's start with working with numbers. So this here we have 343 to the 1/3 power. Now, I don't know about you, but I have no idea what is how to take the power of 343 with a fraction. But I do know how to work with roots. So what I'm going to do here is I am going to change this as a radical. So if I wrote this as a radical, this is going to be 343 to the first power, right? You can write this to the first power. And then the outside here would be a 3, because it'd be a cube root, because that's what's in our denominator, it looks like, so the cube root. So looking at this here, this is saying, what is the cube root of 343, right? Well, in that case, I can use my calculator if you hit math on the TI-84, and then you hit option 5, I believe. You'll get this symbol, and then you can stick in any type of number or root, and then whatever number you're using. So in this case, let's break this down with a factor tree, or if you use the option 5. But if you break this down with the factor tree, 49 times 7 gives you 343, and 49 can be broken down as 7 times 7. So looking at this, I have a triple of 7s. So in this case, the cube root of 343 is 7. And that's it. I just arrived at my answer. Let's try out B next. So B is like the same issue. I don't know how to take the 128 to the power of 2 over 3. So what I do is I change it to a radical. So this here, I can write it as 125 squared to the third power, right? And so when I look at this, I can see that I have to square the 125 and then cube root it. And that is terrible, right? Because squaring 125 is going to give me a ginormous number. I can do it. It's just going to be working with large numbers. So here's what I do to be more strategic. Because from the belt work, I know that the order of the root and exponents doesn't matter. I'm going to actually take the cube root of this first and then square it. Here's why. When you take a root of anything, you make the number smaller. Whereas when you take exponents, okay, you're going to make the number bigger. So if I take the cube root of 125, we've done this quite a few times already, but the cube root of 125 is 5, and then I'm left with the square. Well, what's 5 squared? That's just 25. And so I have arrived at my answer, which is a lot easier than if I had taken 125, squared it, got a big number, and then tried to take the cube root of it, all just to get 25, right? So know that you have the flexibility to switch back and forth from, instead of taking an exponent, but to take the cube root of it first, or take the root of it first, especially when you're handling with large numbers underneath the root. So like this one here, notice that this is 256 in the root, right? And so notice that we are taking the root of this first, which might be better because in this case, we're making the number smaller and then trying to take the exponent of it. So I'm actually going to plug this in the calculator, the 8 root of 256. Feel free to use that tip there to press that in your calculator. But the 8th root of 256 is 2, and then I have a 3 out here. And then 2 to the third power, well, that's like 2 times 2 times 2. So 2 times 2 gives me 4. 4 times 2 gives me 8. So it looks like I have 8 as my answer. Okay, last but not least, we have this part D. And D here has this all in parentheses and the outside being squared. So here's how I'm going to handle it. I'm not going to worry too much about what's in the parentheses. I want to take care of that power. So I'm going to rewrite this as an exponent form and try to reduce the power. This is what I mean. I'm going to rewrite it as an exponent. So parentheses 3g, and if I wrote this as a rational exponent, this exponent is a 2, and that's my root, my 4. So I have this being 2 over 4, but I can reduce that to 1/2. Now, you can keep your answer like this. There's nothing wrong with it. Or another way to write this is the square root of 3g, right? Because 2 is the root, so this means that this is a square root. And the power here, the exponent, is a 1. So I would write this 3g to the first power, which I could put the 1 here, but I don't need to. So you can either write your answer like this, or you can write your answer like this. I will take both answers. Okay, last slide for today. So let's take a look at simplifying expressions now. Now we're going to add in some multiplication, some negative exponents, and some division. So before we get started in these 4 problems, let's talk about exponent rules. So the first semester you learned that if you multiply two of the same bases, you add the exponents. So in this case, this rule is going to be a plus b for our new x if I multiply. Whereas if you were doing division and you had xa over xb, you would have to subtract the exponents. And it's really important that you subtract the numerator exponent with the denominator exponent. Notice I have a minus b, not b minus a. And last but not least, let's talk about negative exponents. So if I have x to the negative 1 power, well, that's just 1 over x. In other words, anytime you have a negative exponent, what you do is you place that in the denominator, okay? Or whichever side that it's in, you're going to place it in the opposite. Here's why. So negative exponents are just talking about the reciprocal, okay? So let me change this to, let me rewrite this as like x to the negative n power, okay? So in this case, what this is saying is this x, I can always write over 1, right? If I put that in parentheses, well, if I flip this, right, if it's a reciprocal, I flip it, I'm going to have 1 on the top and x on the bottom. And because I flipped it, now this is a positive exponent, n, and there is our new value. So in this case, anytime you see a negative exponent, you're going to basically do the reciprocal or place it in the opposite side. If it was in the bottom, then it gets to be in the top. If it was in the top, then it gets to be in the bottom. So let's try some of these problems out. So the first one here is multiplying a with another a, so the bases are the same. So that means I get to add the exponents here. So let's do this to the side here. 2, 7 plus 4 over 7, well, they have common denominators, are both 7. So I get to add the numerator. So 2 plus 4 gives me 6, and do not add the denominators, they stay the same. So in this case, my answer is going to be a to the 6 over 7 power. And that is my answer. Now, what if I also wanted to write this as a radical, you know? So if I wanted to write this as a radical, let's just practice this skill. This would be a to the 6th power, and then the root would be 7. And so that is also a valid answer. So I am going to, sorry, let me fix that real quick. And so for this case, you can write your answer like this one or this one here. Okay, let's try B next. So it's, again, multiplication, but it looks like if I add these two, let's do this to the side here. 2 over 3 plus 1 over 6, they don't have a common denominator, so I have to make it into, make it have the same denominator. So I have to multiply this 3 by 2. So in this case, I have to multiply the top by 2. So 2 times 2 gives me 4, 2 times 3 gives me 6. If I add these two, I end up having 5 over 6. So if I multiply these two x's, I get x to the 5 over 6 power, or you can write this as the square root of, not the square root of x, the cube root to the 5th power, right? Because 5 is in the numerator, 6 is in the denominator. So you can write your answer like this, or you can write your answer like this. Okay, so part C, we have a negative exponent. And in general, we don't ever want to have a negative exponent. So we try to make it positive. So to do that, to make it positive, let's build ourselves a fraction. And we're going to put this b in the denominator to make it positive. So if I put b in the denominator, the exponent 5 over 7 now gets to be a positive 5 over 7. So with this being said, what goes in my numerator then? Well, by default, it will always be 1. And so you can keep your answer like this because now the exponent's positive, or you can write it as a radical. So as a radical, it would be 1 over the root, 7th root, b to the 5th power. And so these are your 2 answers that you could write. Okay, last but not least, we have part D. And so for part D, notice that I have a root, a radical on the top and the bottom, and I'm dividing. So first, I'm not sure how to divide 2 things like this if they have different roots, right? I can't combine these roots and join them together. So what I'm going to do is I'm going to change them into exponents. So I'm going to rewrite both the top and bottom as an exponent. So this x, the inside here, the exponent is a 1, right? X to the 1st power. So I can write this x 1 over 4. Whereas the bottom x, this is also a 1 on the inside, I can write this as 1 over 3. And so if I look at these 2 here, this is really saying I'm doing x 1/4 minus 1/3, right? I'm subtracting the exponents. So to the side here, I'm going to work that out. So 1/4 minus 1/3, well, they need common denominators if we're subtracting. So this 4 needs a 3, and this top needs a 3, because I want the denominator to both be 12, because that's the, looks like the least greatest. So this is going to be multiplied by 4, and the top will be multiplied by 4. So I'm going to get 3 over 12 if I multiply that across. And then 1 times 4 gives me 4. 3 times 4 gives me 12. If I subtract, I get negative 1 over 12. So looking at this, that's my new exponent. So this is x to the negative 1/12. Now, in this case, are we done? No, because we still have a negative exponent here. So what we have to do is make it a positive exponent. So let's go ahead and do that by putting it in the denominator. So we're putting it in the denominator, and we would have 1 over x to the 1/12 power in the denominator. Let me write that x just a little bit bigger so that it looks like an exponent. Okay, so now we can see that our exponent is a positive, but you don't have to write your answer like this. You can also write it as 1, the root of 12, and then x in the inside, and it would be to the 1st power. So you could write that 1 there if you wanted to. So you can write your answer like this or like this. Okay, hopefully that was helpful for your notes, and then try out the problems on page 3 of packet 9. I hope that you found this helpful.